In this video, we're going to look at the structure of an atom and how to calculate the number of protons, neutrons, and electrons inside the atom. So you can see on the screen at the top, if you look up here, we've got a model of the atom there. That's one of the ones that you should be familiar with. What we've got in terms of the atom is we've got a central part, which we've got highlighted here, which we're going to call the nucleus. That contains two particles. You've got the positive particles, which are protons, and you've got the neutral particles, which we call neutrons. Around the outside then we have what we call shells or orbits, and these orbit the nucleus, and inside there we have another type of particle which is known as the electron. You should also be aware of the relative masses and relative charges of the particles inside the atom. First of all, we've got a proton. A proton's mass is relative to the proton, so it's a mass of 1. Comparing that to the neutron has a relative mass of 1 as well, because it's the same size as the proton. An electron, however, is much smaller, and that has a relative mass of a 1 over 2,000. It's much, much smaller than a proton or a neutron. You could also write there almost 0 for its relative mass at GCSE. In terms of charges, we've already mentioned that protons are positive, so they're plus 1. The neutron, the NEUT part, means it's neutral, which means it's got a charge of 0. And the electron has the opposite charge of a proton, which we call minus 1. That gives you a quick overview of the structure of the atom. It will also be useful to look at isotopes and ions to help us with our calculations later. So an isotope is an atom with the same element, the same number of protons, but a different number of neutrons. And we can see here we've got two isotopes of carbon, carbon-14 and carbon-12. They both have a proton number of 6 because they've got the same number of protons, but they've got a different nucleon number, which means that carbon-14 has 2 more neutrons than carbon-12. We also need to be aware of ions. So ions are atoms that have lost or gained electrons, resulting in an overall charge. So we can see here we've got a helium nucleus, because we've got 2 protons and 2 neutrons. Around this in its orbit, we've got 3 electrons in this case, which gives it a charge of minus 1, because we gained an electron. Therefore, the ion becomes negative. Whereas the same helium atom here has lost an electron. It should have 2 electrons to begin with, and therefore has got a positive charge. So if an atom loses an electron, it has a positive charge and makes a positive ion. If an atom gains an electron, it gains a negative charge and becomes a negative ion. So we are now going to look at how we calculate the number of protons, neutrons, and electrons inside an atom. So we've got 2 values that we need to look at. So at the top here, we've got the mass number of an atom. That's the total number of protons and neutrons that it contains. Now, if you go back to the original slide when we talked about them, the reason we're only talking about protons and neutrons there is because they both have a relative charge of 1. Whereas the bottom number, we call the atomic number, and that just gives us a number of protons. Now, for an atom, the atoms are neutral, and the reason they're neutral is because they contain equal amounts of protons and electrons. So if you've got 6 protons in an atom, we are likely to have 6 electrons. We will have 6 electrons if it's an atom. The only case the electron number will be different is if it was an ion. So when it comes to calculating these values, the first thing we do is we look at the proton number, which is 6, or the atomic number there, as we call it in chemistry. We've got 6 protons, so that value is 6. Because this is an atom, the number of electrons is also 6. To find the number of neutrons, we're going to use this number 12, at the top, and we're going to subtract from that the 6, which was the proton number. And that will give us an answer, again, of 6. So carbon-12 has 6 protons, 6 electrons, and 6 neutrons. If we go down and look at carbon-14, though, remember this is an isotope, so it's got a different number of neutrons. We can go through the same process as we did before. But the first thing to do is look at the number of protons. So we can see the number of protons is 6. As it's an atom and it's neutral, it means it must have the same number of electrons, so that becomes 6 as well. Whereas what now we want to look at is the number of neutrons. So you've got 14 at the top, so you do 14, take away the 6, and that will give us a value, which is our answer, of 8. So carbon-14 has 8 neutrons, 6 protons, and 6 electrons. So on this slide, we've got some questions for you to have a go at now. What we're going to do is I'm going to model you the first two, and then I'll give you some time to complete this yourself, and I'll go through the rest of the answers with you. So the first one, again, we're going through the same process as we've done before. First thing to do is look at the atomic number. So we've got 8 protons. Because it's an atom, we know if it was an ion, because it would have a charge here, like these two are ions, because they've got charges. We know it must have the same number of electrons, so electrons will be equal to 8 as well. To find the number of neutrons, we take the top number of 18, and we're going to subtract the 8 from there to get a value of 10. So the first one we found out has got 10 neutrons, 8 protons, and 8 electrons. The second example is an ion this time, so we've got this idea of this +2 part. Okay, so you can see that there, +2. So the first thing that we're going to do is we're going to go through the same process as before. We look at the atomic number. That gives us the number of protons. That's always going to be 8. The electrons, though, we've got +2. So if it's become a positive ion, it's lost electrons. The fact it's got a charge of +2 means it's lost 2 electrons. So the electrons are going to be 2 fewer than protons. So I'm going to say 8 minus the 2 here to get 6. And then to find neutrons, we take the top number of 17. From that, we're going to minus the 8. And we're going to get an answer of 17 minus 8 will give us an answer of 9. Okay, if you can pause the video here, I'd like you to go through the rest of these questions, and I'll run through the answers with you in a few moments' time. Okay, so I think you've had a chance now to hopefully go through these and work them out. I'm just going to quickly run through the ones that are left with you, just so you can see how they're done, and you can mark your work, ideally using a green pen as we go through them. So the first one here is lithium. So again, we look at the 3 protons. And because it's an atom, it will have 3 electrons. In terms of neutrons, we look at the top number. So 7. Take away the 3. And that will give us a value of 4. Moving on to the next sheet, we're going to have protons and neutrons, electrons again. So we always start with circling out the number of protons, which is 11. Because it's an atom again, we'll have the same number of electrons, so that should be 11. And then to work out the number of neutrons, we're going to do 23 minus 11, which should give us an answer of 12. It's got 12 neutrons there. The next one's an ion, because we've got the -1 charge, so we know it's an ion, makes it slightly harder. We've got 17 protons. If we've got a -1 charge, that means it's gained an electron. So here we're going to take the 17, I'm going to add the 1. That'll give us a value of 18 for our electrons. And then in terms of neutrons, again, the same process applies. We're doing 36, take away 17, and that gives us a value of 19. On to the last one then, it's an atom again this time, so there's no ions to worry about, so the electron number will be the same as the proton number. We've got 26 protons. Because it's an atom, we've got 26 electrons. 56 is our nucleon number, or our mass number, so we're going to do 56, take away the number of protons, which is 26, and we'll find our answer is equal to 30 in this case. Okay, so now that you've done these questions, hopefully you're feeling more confident with how to determine the number of protons, neutrons, and electrons for an atom, and hopefully you're also feeling more confident with atomic structure. There is an additional worksheet for you to move on to now. I hope you found this lesson useful, and I look forward to working with you again soon. Thank you, and goodbye.